moving along. So now we're on the first example, and what I want to do is just show how on this first example, regular division is just really the same as this polynomial division. So, right, if we were doing example 1 and just these numbers, we would first do 4 times what, right? Same question, 4 times what gives us 6, which we don't have a number, so we put 4 times 1, which is 4. And then we do a subtraction here, 6 minus 4, that gives us 2. And then we bring down our 0, and we ask the same question, 4 times what gives us 20. In this case, we have a nice easy number, and we get 15, right? So that's the same process we're going to use for this. What we're going to look at, instead of this number 4, when we look at this x minus 2, we really are just looking at x and x squared, right? That's the first thing we're going to look at. So we're asking ourselves, x times what gives us x squared, right? Which is nothing crazy here. X times x is going to give us x squared. Why did I write it over here, over the second one, when I said we were just talking about this orange thing? Well, I wrote it there because there's 1, 2 things here. And so I'm just counting 1, 2 things over, right? So that's it. Get that in there. That's our technique. Now, well, what do I write below this? Well, over here, we would write 4 times 1 gives us 4. That's what we wrote there. We're going to do something similarly, and we're going to do x times this whole thing. All right, so we're going to use a little scratch side over here, x times x minus 2. What does that give us? X times x is x squared. That's what we wanted. And x times a negative 2 is a negative 2x. So we're going to write that there, x squared minus 2x. But what did we do last time? Well, over here, we subtracted, right? So I'm not going to add these expressions. I'm going to subtract them, and I'm going to write a minus. I'm going to put both of those in parentheses just to keep track of that. And now let's go through them individually. What is x squared minus x squared? Well, nothing, right? 0. Good. What is x minus a negative 2x? That's the same thing as saying x plus 2x. So it's going to give us 3x. What did I do last time? I brought down the 0 and bringing down the negative 6 here. And so now we're just asking ourselves a new question, right? Which is x times what gives us 3x, right? So what do you multiply x by to get 3x? Yeah, just positive 3, right? So we're at x plus 3. Same thing. I'm going to write this 3 down kind of on the side and do some scratch work. 3 times x plus, wrong, 3 times x minus 2. And we're going to distribute that 3x minus 6. I'm going to write 3x minus 6. What are we doing here? No, we're not adding, right? We're still subtracting. And so what is 3x minus 3x? Nothing. What is a negative 6 minus a negative 6? Negative 6 plus 6, that's 0. And so we get no remainder. And let's go back real quick. It says it can be used to factor. So what have we just found? Because there's no remainder, we've shown that x plus 3 and x minus 2, but especially that x minus 2, by dividing this polynomial by x minus 2, we've shown that that is a factor, right? So this is a factor. That's what we found. All right, pause, think about it, rewatch it if you need to, and then we'll move to example 2. All right, if you're at that spot, that means you've written everything down in the first section. You've gone through example 1, you understand example 1, you've maybe watched that twice, and you're ready for example 2. Example 2, we've got the same setup. We've got, well, another regular division. So let's work on that. And we're just going to go through it super quick. So 4 times what? Same thing. 4 times 1 is going to give us a number that's 6 or less. It gives us 4. And then what next? Well, I subtract, right? 6 minus 4 gives me 2. I bring this 3 down, that's 23. And I'm going to put 15 here again. I'm going to put a 5. 4 times 5 is 20. But this time I'm left with 3. And so, of course, we can continue on and get a decimal, see if it ever, evens out, or we can write it as a fraction. That's the thing I want to emphasize here. So if we wrote it as a fraction, we would have 15. We would take our remainder, 3, and we would write it over whatever we had that we were dividing by, which is 4. So we'd have 15 and 3/4. That would be what we wrote, and that would be accurate. So same thing is going to apply here. Same principles for our polynomial. So again, we're going to say, all right, what times x gives us, and look, we got a number here this time, gives us 2x squared. All right, what times x gives us 2x squared? Well, yep, it gives us 2x, right? 2x times x gives us 2x squared. So we're going to write a 2x here. Again, because we have 1, 2 things. So we're counting over 1, 2. That's why we're writing it there. And then just like before, we're going to do scratch work on the side. So I'm going to write 2x on the side here, write x minus 2, do that multiplication, and then get 2x squared minus 4x. So we're going to write that here, 2x squared minus 4x. And what do? We subtract it. So let's subtract it. 2x squared minus 2x squared, nothing. Cool. 3x minus a negative. That's double negative, so it's adding. 3x plus 4x, 7x minus 4. Cool. What do we do, right? What's the next step? Yeah, next step is x times what, right? The same x times what gives us 7x. Right, just 7, right? So we're going to write plus 7. We'll do our scratch work. Just do it here. 7 times x minus 2. What is that going to give us? 7x minus 14. So we're going to write 7x minus 14. What are we doing? We're subtracting that. Cool. We subtract it. 7x minus 7x is 0. Tells us we're doing the right thing. That should always be 0, that first thing. And then a negative 4. And what is that? Double negative. Yep, double negative 4 plus 14. That leaves us with a positive 10. So what do? Well, same thing we did before. We're going to take that remainder, just like that 3, put it over that divisor, that 4. So we're going to do plus 10. What were we dividing by? Oh, we're dividing by x minus 2. So plus 10 over x minus 2. And that whole thing is going to be our answer. A couple quick things. Did we have a remainder? Yes. Since we had a remainder, that means that x minus 2 is not a factor. Last time we learned that x minus 2 was a factor, right? It was a factor. It's a factor because there's no remainder. This time we've learned that it's not a factor. And when we do this division, we get 2x plus 7 plus 10 divided by x minus 2. Perfect. Yeah, get that down. Watch it twice if you need to. I mean that. And then we're going to move to example 3, which is a little stickier. All right, here's our new one. Example 3. Determine if 9x minus 5 is a factor of 9x to the 4th minus 5x cubed minus 36x plus 22. Okay, what does that even mean? Well, we already know. If there's no remainder, like in example 1, it's a factor. If there is a remainder, like in example 2, it's not a factor. So we're just dividing it, same thing. The only thing that's different is, just want you to, I mean, obviously it's longer and whatever, but just notice 9x to the 4th, 5x cubed, and then a regular x. Man, it seems like something's missing, right? Yeah, there's a 0 kind of in between, right? There's no x squared that's mentioned there, right? Well, that matters. That matters a lot. That x squared isn't there. So let's write it out. I'm going to write it down here. 9x to the 4th minus 5x cubed. Remember, there's no x squared. Okay, but we need a placeholder for that, right? So that's just nothing, but we need a placeholder. It's going to be very important. So we're going to put that in there. And anytime there's something missing, whether it's this number, whether it's any terms in between, we're going to need a placeholder for that stuff. Minus 36x plus 22. And then we're write a 9x minus 5 here. And from here, it's just the same thing, right? As before, 9 times what gives us 9, 9x times what gives us 9x to the 4th. Okay, so that's the first question you should be asking yourself. Same process, right? So we should get x cubed because 9x times x cubed gives us 9x to the 4th. And so way over here, I'm going to do some of that scratch work. So x cubed times 9x minus 5. Let's just multiply that really quickly. And that's what I get, 9x to the 4th minus 5x cubed. That's what I'm going to write here. 9x to the 4th minus 5x cubed. Oh, I mean, that matches it perfectly. So it's kind of nice, right? So we subtract it. And we've subtracted, we're going to get 0 here, 0 here. So I'm going to bring down this term, this x squared term, even though it's a 0. And so how many times does 9x minus 5 go into, right, this 0? Well, 0 times. So we can kind of just write 0x squared. We're just doing that for a placeholder, right? We're gonna do that for very long. And then we're gonna drop down this minus 36x term. All right, now how many times does 9x go into a negative 36x? Well, I can do that, right? That's 9 times a negative 4x. So let's use a negative 4x times 9x minus 5. What are we gonna get? Negative 36 x squared. Well, that's no good, right? We don't want a negative 36x squared, right? We don't want x squared. We want just x. So what has happened, right? We've done something wrong. We need there to be no x here, right? We just need a 9x times a negative 4. So let's get rid of that x. There we go. Just a negative 4 times that. There's no squared. Good. So negative 4 times 9x, negative 36. Negative 4 times a negative 5. That's a positive 20. So we're going to go ahead and write that down. Negative 36x plus 20. What are we doing? Same thing we always do. We're subtracting. And look at this. We got to bring that down too. And so we're going to get negative 36x plus 36x. That's 0. Positive 22 minus 20, that's a positive 2. So yeah, so here's a, like I said, this is a stickier problem. That's a stickier problem. And so we're really done. And what have we found? We found that this 2 doesn't really have a home, right? It's not going to get canceled out. In fact, really over here with our placeholders, when we made this mistake of this minus 4x, that minus 4 really belonged here, right? And so I know this is like I said, this is a little messy, but that is the nature of these long division problems. And so we've got an x cubed, we've got a minus 4, we got 2 placeholders, said they're important, I meant it, right? And then we end up with a 2 at the end. And what does that mean? Well, it means 2 things, right? It means that it's a remainder. So we need to write a plus 2 over 9x minus 5, right? And our answer